All right, today we've got a project. We're gonna build a server rack battery. So I already had this battery from Beene Brothers, and it's a 130 amp hour, 48 volt server rack battery. And I got this, it was already pre-built, but I decided I needed another one. And I was given the option to build it myself. So I took him up on that. I don't think this is something that he normally does, but I thought it would be fun to just get the parts and put it together and do a video and take you guys along for the ride. So I've got the cells here. These are 130 amp hour lithium iron phosphate cells. I've got 16 of these. And then I've got the case. We've got our terminals. We've got our wiring and screws and other hardware. Here's the BMS board. We have our display. We have a little interface board for the BMS. This is the front ports. And then we have all of our bus bars and nuts for the cells. And then we have our cell separation boards here. That way we can make sure each cell is isolated from one another. So let's get started. All right, so I've got this battery opened up. That way I can use it as a reference in building this one. And I went ahead and layered some fiberboard down at the bottom just for some extra protection. And normally I would parallel all the cells together and charge them up to top balance them. But I'm not going to do that this time. I'm actually just going to go ahead and assemble them all in series. I'll charge the whole pack up, and it's very likely that some of them will not be balanced. I'm completely aware of that. But the way that I'm going to balance them, if I need to, is I'm just going to hook up this active balancer, the 16S active balancer, and I'll let this thing balance my cells. This is what Christopher Beene actually does when he builds these batteries. He just goes ahead and puts them all in series, and then he hooks up an active balancer to let it balance the whole pack, and then he removes the active balancer. That's a really good idea. And so I'm going to do the same thing, because that's way faster. Because putting these cells all in parallel and charging them up to 100% to top balance them, that can really take a long time. All right, so let's go ahead and put this back fiberboard in on the back side there. And then we need one for the side. And then we'll go ahead and put this cell in place. We'll put a separator in here, and then we'll put this cell in place. All right, check it out. We have all 16 cells in place. So now would be a really good time to make sure we have them in the correct polarity. So if we look at our reference battery, we see that our main negative is here, our main positive is here, but we can just look at the orientation of these cells. So we've got a positive here, we got a positive here. So negative, positive, negative, positive, negative, positive, negative is what we want to see. And at the top row is the same. We want positive, negative, positive, negative, positive, negative, positive, negative. So next step, we'll go ahead and put these bars that hold these cells into place. Okay, so that first bar is in place. We need to put the second one in. And these have little pieces of foam on the bottom to press on the top of the cells to keep them snug. Okay, so now we need to put this piece of fiberboard on the front side of the cells. But there's a gap right here between the cells and the BMS mount area, so we need to use this foam to take up that gap. However, I'm going to have to cut these down because I think these were included because there could be different size cells you could use in this case, and so they're not exactly the right size. So what I need to do is mark that and then cut these down. I need to trim these down so I can fit those down in there. Alright, so I've got a mark right there. I'll go ahead and cut this one and make sure it fits properly. Okay, let's try it. Yeah, I think that's perfect. It's slightly snug, but it does fit in there. And so that's good because that's kind of what I want it to be. I want it to be a little snug. All right, I'm going to cut the rest of them to that and then I'll install them. All right, so I got those pieces of high density foam cut down to size and I've got them stuck to this fiberboard. So let's go ahead and get this installed. There we go. Perfect, fits nice and snug. That's exactly what we want. All right, so now I want to build out this front panel, and I've got all the components laid out. So let's get started. We'll install the screen. Let's install the comms board. All right, that's looking better. So we got our comms installed. We got our little screen here. Oh, we need to take out the little protective film. There we go. And then we've got a sticker that goes over that. So let's go ahead and put that on. All right, I think that went on pretty well. And this also has a little protective film on it, but I'm going to leave it on for right now. So next we can put our terminals on. All right, and lastly we have our circuit breaker. All right, so I think we've got the front panel all assembled now. All right, so now let's install this big, beautiful BMS. All right, so we got that guy bolted in. Now I'm going to figure out how I'm going to route the sense wires and the temperature sensors. All right, so I got this first set of wires ran, and it was fairly easy. I'm going to run the second set now, and it'll start over here and come across. I also went ahead and got the negative cables on the BMS wired to the most negative cell, and then the output of the BMS here that's going to go to the terminal on the front panel. And I just picked up these crimpers, and these have been working really well, and that's what I used to crimp this first set of wires on. See there? And it's a very good solid crimper, so I'm happy with that. And they were fairly budget, and it crimps. Let's see, it says 22 all the way up to 6 gauge, and these are for non-insulated terminals. So these are non-insulated terminals, and that's what these crimpers are used for. And it's easy, just put the terminal in there, kind of ratchet it down, and it'll hold it. All right, so I'm going to get this next set of wires on, and I'll be right back. Okay, so here's the last crimp on this wire set, and I want to show you how well this crimper works. There we go. In it. Very solid. So now we can put those bus bars on. All right, so we're basically halfway done on these sense wires. 2 more sets to do, so I'll go ahead and wire this section up, and I'll be back when I'm completed with that. All right, so I've got it all wired up. So all the battery sense wires are connected. I've got them all tied up. I've got the temperature sensors underneath the heat shrink on these bus bars. And then I went ahead and put the wires on the front here that connect to the front panel. So really all I need to do is just hook the front panel up, and this thing's ready to fire up. So let's just go ahead and do that. All right, so the front panel's on. Last connection I gotta make is the positive, and then just plug the power into the BMS. All right, so let's plug in the BMS power and see what happens. Oh, all right, it came on actually. Very nice. There we go. Let's check out our cell voltages. 3, 2, 4 on all 4 of those. 3, 2, 4 on all 4 of those. 3, 2, 4 on all those. And 324 on the last set. Very nice. So let's charge this guy up now. All right, so I got the charger hooked up to the battery, and all we got to do now is turn it on. It should start charging. Okay, I heard the charger come on. Let's see if we can read something here. Okay, now, yep, it's showing that we're charging. And there we go, we're getting 9.94 amps going into the battery. All right, so I'm just gonna let that thing sit there and charge up. We'll take a look at it after the charge stops to determine if we do have some cells that need to be balanced. And if we do, we'll just hook up the active balancer to the whole pack and just let it balance. All right, I'll be back when it's done charging. All right, guys, so the charger has stopped, and that is because cell 6, I think it peaked up to the cutoff voltage. It's 3.4 right now, but I'm pretty sure it was higher. Yeah, all the other ones are still 3.3. Yeah, so I think it's at cell 6. So what we'll do right now is we're going to wire in the active balancer, just temporarily. All right, I'll be back. All right, guys, so I got the active balancer wired in. It's all plugged up. I got the charger running again. And as you can see, our cell 6 is rising still because we got the charger on it. But we should be taking power out of it via the balancer. So we can check that. So number 6, 1, 2, 3, 4, 5, 6. So 6 is that green wire right there. Let's see if we got something coming out. Yep, we do. We have 0.5 amp coming out of that cell number 6. So the balancer is taking power out of it to put it into the other cells. All right, fantastic. So yeah, I'm just gonna let that set and do its job and balance the pack. All right, now let's check out how awesomely balanced these cells are after letting the balancer run for a while. All right, so here we go. 3504, 3503, 3503, 3504, 3503, 3503, 3504, 3504. The same thing. And then for all the rest of them, the same thing. So very good balance. Very happy with that. So let's turn the charge on one more time just to see how well the balance stays. Oh, actually I need to plug the charger in. Okay. So now the charger's back on. So let's see if this stays balanced as it's pushing 3.6. Yeah, it's still pretty close. Okay, we got 3.6 on cell 3. The rest of them are not far behind. There we go, we got 3.6. We got 3.6, 3.6. We got 3.6 on all of them. So yeah, very nice. I'm happy with this balance here. Yeah, it's great. All right, so all I really need to do is remove this balancer. I don't need it in there any longer since we're nice and balanced, and just button the whole thing up. But I think that's going to be it for the video. I hope you guys enjoyed this build. Let me know what you think. I'll leave some links in the descriptions for some stuff that I've used here, and I'll catch you in the next one.